What is a definition of a random variable? A random variable that is represented by x is a numerical value that is associated with each outcome of a probability experiment. We can divide up a random variable x to discrete and continuous random variable. Each one has a different probability. A random variable is discrete when it has a finite or countable number of possible outcomes that can be listed. For example, x represents the number of students in this class. I can easily count them. 1, 2, 3, 4, 5. It stops at some points. The key word is the number of. Another example for you. X represents the number of banks in San Jose, California. The number of means that, hey, we can easily, not much easily, we can count them. How many banks are in San Jose, California? So why it is important for us? Each value of a discrete random variable can be assigned a probability. What are we going to do? We're going to list each value of a random variable with its corresponding probability, which is basically the relative frequency that used before. Then you're forming a discrete probability distribution. What are the guidelines here? First of all, in constructing a discrete probability distribution, in the case that x is a discrete random variable with possible outcomes x1, x2, x3, and xn, first of all, make a frequency distribution for the possible outcomes. This is what we learned before. Then, find the sum of all frequencies. 3, find the probability of each possible outcome by dividing its frequency by the sum of the frequencies. In the next step, check that each probability is between 0 to 1, like 21%, 13%, 60%, 71.5%, and so on. If you add them all together, it must be equal to 100% or 1. So you're making sure all the steps are correct. Attention, please. In building the probability, we are basically finding the relative frequency, which is the frequency of each class, in this case, the frequency of each value divided by the sample size, or F over N. So we are using the exact same formula that we used before in constructing a frequency table. Nothing new. Let me give you an example. An industrial psychologist administered a personality inventory test for passive-aggressive traits to 150 employees. So the total number of people are 150. Each individual was given a score from 1 to 5, where 1 is extremely passive and 5 is extremely aggressive. A score of 3 indicated neither trait. We want to construct a frequency distribution for the probability of discrete random variables, and then we're going to visualize it. So take a look. Score 1, 24 people scored 1. 33 people scored 2. 42 people has neither of these traits. 30 people got score 4, 21 people got score 5. So for example, if you want to think about it in a class, suppose we have a test. The test scores are 1, 2, 3, 4, 5. 5 is the maximum, 1 is the minimum. I have 150 students. 24 students got score 1, 33 students got score 2, 42 students got score 3, 30 students got score 4, and 21 students got the perfect score 5. We want to build the frequency distribution or probability distribution for X values. So if one of my friends asking, hey, what is the average score? I can look at the data and give them the answer. What are you going to do? You're going to divide the frequency of each score by the total number of individuals in the study. So the probability of score 1 is 24, which is the frequency or the number of people who got score 1, which is 24, divided by 150, which is about 16%. Next, the probability of score 2, which is 33, frequency of the number of people who got 2 divided by 150, or 22%. The next probability is for 3. The probability that you randomly select a person and that person got 3 is 42 out of 150, or 28%. The probability of 4 is 30 over 150. The probability of 5, the perfect score in a quiz example, is 14%. Well, how do we visualize this? First of all, on the horizontal line, you're going to list all the scores, Y scores, because scores are your variable. Variable X is 1 or 2 or 3 or 4 or 5, which lands on the horizontal line. On the vertical line, you have the probability. Why we are using 30% as the maximum? Because you have 16%, 22%, 28%, 20%, and 14%. The maximum is 28%. So let us just scale it to 30%. We don't have to go to 40% or 50%. We can just stop at this point. The probability of score 1, as you know, is 16%. So as you can see, the bar stops at 16%. The second score, 2, has probability 22%. So as you can see, your bar is a little bit taller. The third, number 3, has 28%. This is the bar with the highest value here. And then you have score 4, 20%. The bar starts going down, decreasing, and then the last score is 14%. So as you can see, obviously, this is the smallest bar here. So this is the distribution of the scores in the class, or in this case, the distribution of these scores in personality inventory tests for 150 employees is located here. Very good. This is one of your Realize It question. You might have question about this, so I want to solve this for you before you jump into your Realize It, or for those of you who already started Realize It and got stuck for this question, the solution for this question is here. First of all, we have some statisticians, a team of statisticians. They went out and then they collected data and information about the number of people who live in different housing, like apartment or different types of housing. X is the number of people. How many people are living in the apartment? How many people are living in that building? So it happens that 1,007,669 property have one resident. Okay, 914,820 have 2 residents. 514,359 has 3 residents. 386,524 has 4 residents. And as you can see, the numbers start decreasing. So take a look. First of all, we want to compute the total number of properties in the table. We're going to add all of these numbers together and it's going to be a large number. We had a big team, we had money, we sent them to 3,124,138 properties. And out of those properties, 1,007,669 has one resident. Okay. We want to find the probability for each one of these. The relative frequency, F divided by N, for the very first X or one resident in those properties is 1,007,669 divided by 3,124,138, which is about 32.3%. So if you randomly select one of these properties, the probability that that property has only one resident is 32.3%. We can continue this process. So what's the probability that you randomly select one of these properties and they have only two residents? It's 914, 820 divided by 3,124,138, which is 29.3%. What if you select one of these property and knock on their door and say, hey, how many residents do you have? That probability is 16.5%. You can continue this process. You just need to divide each one of these frequencies by the total number. And as you can see, the probability starts decreasing. So if you knock on one of these property doors and the probability that they have more than 9 people living in that property is very small, 0.4%. So how do we visualize this? First of all, on the horizontal line, you have X values. What are X? The number of people living in those properties. On the vertical line, as you remember, you're going to use the relative frequency or the probability. You're going to stop at 0.32 or 32% because this is 32.3% is the maximum probability. So the very first bar, which is the tallest bar, then you have 29.3%, then you have 16.5%, then you have 12.4%, and you can continue. As you can see, the probabilities start decreasing. So the graph starts decreasing in size. Obviously, you have a tail on the right-hand side. So the graph is skewed to the right. The tail is on the right. You have a data set that are skewed to the right-hand side. And as you can see, the majority of the probabilities are for 1, 2, 3, 4, add them together. What is the mean? What's the average? By looking at the data, I can say that, hey, the average is in between 2 or 3. For exact calculation, I have to use my calculator or a software that helped me to do the calculation. Now, if I ask you to find a probability that X is less than equals to 4, it is going to be 32.3%, which is the probability that X is 1 less than equals to 4 is 1, 2, 3, 4. Plus the probability that it is 2, which is 29.3%, plus the probability it is 3, which is 16.5%. And finally, add it to the probability that X is equal to 4 or 12.4%. And if you add all of these together, you get 90.5%. So the probability that you have at most for residents is 90.5%. This is one of the most important use of the relative frequency. It helps you to do the calculation for cumulative probability. Let's take a look at another question. Suppose I ask you to find the probability that X is more than 5. What is the probability that you have more than 5 people living in those properties. You have 6 or 7 or 8 or 9. So you have to add all of these probabilities together. There is no intersection between them. People who live in one property are not living in the second property. They live in just one property. So there is no intersection. First of all, the probability that x is 6 is 0.023 or 2.3%. The probability that it is 7, it's going to be 1%. The probability that it is 8, as you can see, it's getting very small, 0.3%. The probability that is more than 9 residents is 0.4%. If you add them together, it's going to be 4%. So the probability that you randomly select one of these properties and you have more than 5 people living in those properties is 4%. And one last question. Suppose I ask you to find the probability that you have between 2 to 4 people living in those properties inclusive. So the probability that x is 2 is 29.3%. The probability that is 3 is 16.5%. And the probability that is 4 is 12.4%. If you add them all together, it's about 58.2%. So first, make sure to create the relative frequency table, and then based on the question, find the probability by adding these numbers together.